Welcome back, students. Uh, in our last session, I think number system 4, that session is number system 4. In that, we discussed the concepts of remainder theorem, and units digit concept. Okay, remainder theorem and units digit concept. These are the two things which we have discussed in our last class. Okay, today we will solve some problems based on these two things. Okay, and then we will try to learn the number of zeros concept. How to find the number of zeros at the end of any given factorial or whatever it may be, product or whatever it may be. We will see the concepts. If possible, we will solve the problems also. So we will quickly solve some problems from remainder theorem and units digit concept, and then we will move to our next concept. Okay, right. So now we will see these questions now. We will see some questions and we will move to the number of zeros concept later on. Right? Right. See here, students, if P is divided by Q, then the maximum possible difference between the minimum possible and maximum possible remainder can be. Okay. We need to tell if P is divided by Q, that means P by Q. Usually we will divide it in this manner, P by Q. Then the maximum possible difference between the minimum possible and maximum possible remainder can be. See here, what is the minimum remainder possible when we divide P with Q? If P is a multiple of Q. For example, if P is a multiple of Q, that means exactly cancelable. Then we will get a remainder of what? We will get a remainder as what? 0. We will get a remainder 0 when P is a multiple of Q. When P is multiple of Q, P is multiple of Q, then remainder will be what? 0. That is, for example, like this. 12 by 3. 12 is a multiple of 3, right? 12 is a multiple of 3. 3 ones, 3 fours. In this case, what will be the remainder? 0. So the minimum remainder. What will be the minimum remainder here? Not only in this case, in any case, the minimum remainder will be what? 0. 0. And similarly, what is the maximum remainder possible when you divide a number with n? In my last class, I clearly mentioned. So the maximum remainder possible will be what? When you divide it with n, it will be n minus 1. But here we are dividing it with what? Q. So the maximum remainder becomes what here? Q minus 1. Q minus 1. About this we discussed in our last session. Okay. So please go through that one if anyone have any doubts. So the minimum remainder will be a 0 and the maximum remainder will be what? Q minus 1. What they are asking us, what is the maximum possible difference between them? That means the difference between these two things. What is the difference between these two things here? Q minus 1 minus 0. Then obviously it becomes what? Q minus 1. So our answer becomes what here? Q minus 1. Q minus 1 will be our answer. Sometimes they may ask us questions based on concepts. So we should be ready for that also. Because of that reason, we are seeing this some basic question. Okay, this question is purely conceptual question. Okay, we should be ready for the next one. What will be the remainder when minus 24.8 is divided by 6? When minus 24.8 is divided by 6. So for time being, students, we will neglect this minus for time being, not completely, for time being. So what we will do, we will try to divide 24.8 with 6. And if we try to find it, see 6 ones, 6 24s. Okay, general method only I will go. 6 fours are 24. When you subtract it, what is the answer you will get here? 0.8. You will get 0.8. Okay, for this, the remainder is 0.8. For this, the remainder is 0.8. But is our question 24.8? No, our question was minus 24.8. So the remainder for minus 24.8 by 6 is, similarly, this becomes minus 0.8. This becomes minus 0.8. Tell me now, will we mark our answer as A? Will we mark our answer as A? No, we should not do that. I have already clearly mentioned you that we will always write our reminders only in positive manner. When we want to write it in your final answer, we will always express the answer in positive one. Because of that reason, what we will do, 6 minus 0.8, that is 5.2. So our answer here becomes 5.2. Our answer here is 5.2, not minus 0.8. Our answer here is 5.2. So please keep this thing in your mind, student, everyone. Okay, our answer here becomes 5.2, not minus 0.8. Okay, clear? Right. Then we will move on. See, to understand this, please watch our previous session. Okay, now. What find the remainder for 3 power 560 by 8? 3 power 560 by 8. In my last class itself, we clearly learned that whenever we have these type of questions, we will try to write the difference between numerator and denominator as 1. Then it becomes easy for us to calculate it. For this, see here, there is 3 power 560 by 8. How we can write the difference between numerator and denominator as 1? Check 3 powers, which is nearer to 8. 3 square is 9, right? 3 square is 9. So instead of 3 power 560, I have some, if I have some like this, something like this, it will be. So my required one is what? Square. For that reason, I will divide my power with 2. Why with 2 means the required one is 2. So 2 2s are, I am going with the basic one only, students. 6 times 8 is 0. Directly I will take it, not an issue. So remainder is 0, right? So there will be no problem. We can split it directly. 3 square whole to the power of 280 by 8. 3 square whole to the power of 280 by 8. Then what happens to this now? 9 to the power of 280 by 8. 9 to the power of 280 by 8. Now check what is the remainder for 9 by 8? 1. And we have what? Power as 280. So our answer becomes what here? 1. So our answer here is 1. See here, students, I have splitted this. Please go to through our last session, session number 4, number system 4. Then it will be easy for you to understand how I have written this and how we are solving these things. Okay. Right. Then we will move to our next question. Now, what is the remainder when 51 into 27 into 35 into 62 into 75 is divided by 100? See here, students, I think this is one of the previous year's UPSC question. Okay, 35 into 62 into 75 by 100. So, what my suggestion is here, students, whenever you see these type of questions, how we need to solve these type of questions. This is very, very important for us. Okay, are you getting my point? Why? Because the question is lengthier. Okay, then how we need to solve these type of questions. If you cancel them, it is fine. Okay, if not, please be careful while solving them. What is the logic behind them is simply don't simplify it. The first thing is we cannot simplify it. If we simplify it, we may go wrong. So even though if you simplify it, what my suggestion is, in order to restore it, for example, what I mean to say is, please see here, students, 32 by let me take 6 for time being. We know what is the remainder here, 2. We know that the remainder is 2 here. The remainder is 2 here. That means if I want to simplify it for timing, what I will do is I will try to simplify it. So if I simplify it, further simplify it, what it becomes? 16 by 3, 2 times. With 2 table, I am cancelling. What is the remainder I will get here? 1. What is the remainder I will get here? 1. But you can simplify it. But after simplifying it, with what table you cancelled here, ma? With 2, right? To restore to its original value, multiply with 2. So that you will get the answer. Similarly, what I will do is, initially I will cancel here. But when I want to write my final answer, to restore it, I will multiply with the same number. That means, see here, students, I will cancel this one. 25 3s, 25 4s. With what I have cancelled here? with 25. Okay, I divided these two with 25. Okay, next I will cancel it with 2 table also. Okay, please remember, with 2 table 2 times and 31 times. Okay, overall I cancelled it with what? 50. Overall I cancelled it with what? 50. So what I need to do is, I need to multiply, after finding the remainder for this, I need to multiply the answer with 50. Why? Because actually I am finding the remainder for the simplified one. I am finding the simplified one. See here, like this. See this example for your better understanding. The remainder for 32 by 6 is actually 2. Okay, what I will do is, I will try to simplify it with 2 table. Okay, now once again to restore it, I will multiply it with 2. In the similar manner, actually I am simplifying this equation. Overall, with what I cancelled 50. Okay, so now I will try to find the remainder. 51 by 2, what will be the remainder? 1. Individual remainder. 27 by 2, 1. 35 by 2, 1. 31 by 2, 1. 3 by 2, 1. Okay, the remainder for this value is what? Actually 1. 1. After simplification, the remainder is 1. But for the actual value, what will be our answer here, ma? But for the actual value, what will be our answer here? Our answer becomes what? 50 into 1. So it becomes 50. So our answer here is 50. Okay, so our answer here is 50. Did you get my point? See here, the actual one is 100, but we are actually dividing it with 2. Why we are dividing it with 2 means, we are cancelling some values and we are writing, we have cancelled it with 50. So in this manner, you can solve these type of questions. Okay, please be careful while restoring it. You can cancel them, but make sure that you people restore its original value. Okay, otherwise it will go completely wrong. Why? Because 1 is also one option given here. So please be careful here, students, everyone. Okay. Right. Next question. This is related to the units digit concept. See here, in my last class itself, I have clearly told you, whenever there is a 5, okay, what will be the unit digit for whatever may be the power of 5? 5 is the unit digit. But for 3 and 2, we will have 4 chances. But remember one thing, in that class itself, I have told you one thing. When you multiply 5 with any even number, what is the unit digit which we will get here? 0. So see here, there is 2 here. What are the chances for 2? We have 2 power 1 is 2. 2 square is 4. 2 cube is 8. 2 power 4 is 6. Actually, it is 16, but I will consider the unit digit, right? So I'm writing here 6. 5 with any even number, what will be the final output? 0. 5 with any even number, what will be the final output? 0. So directly, without finding anything here, by seeing the question for once, we can say that our answer is 0 here. Excuse. Our answer is 0 here. 5 with any number. 5 with any even number, what is the unit digit which we will get here? 0. Okay. Using that logic, we will mark our answer as 0 here. Okay. Clear? Directly, without knowing the unit digits, what are the unit digits, we can directly say that our answer becomes 0 in this case. Okay. Right. The last digit in the expansions of 3-digit numbers, 34x and 34x whole to the power of 43 and 44 are 7 and 1 respectively. Last digit means what? Nothing but unit digit only. He is speaking about unit digit. What can be said about the value of x? See here, students. Yesterday we have seen, when we will get the unit digits as 7 and 1, generally, in general, in which cases we will get if the power is 1. But for 1, always 1 only, right? But here there are 2 different things, that is 7 and 1. So what for which unit digits do we have, where we are getting the unit digit as 1? 3 and 7, right? 3 power 1 is 3. 3 square is 9. 3 cube is 27. So unit digit is 1. 3 power 4 is 81. Unit digit is 1. Similarly, 7 power 1 was 7. 7 square is 49, unit digit is 9. 7 cube is 343, unit digit is 3. Next 7 power 4, something value, but unit digit is 1. 3 into 7, 21. So we will have 1 and 2 will go as a carry. So there are only two chances for us. Either the units digit should be 3 or the units digit should be 7. Then only we will have the possibility. Now please check the options my here. Actually, if you check the options, there is only one option which is suitable for us. What is that? 3. Directly you can mark our answer as 3. But if you want to cross verify it, I have told you, right, we will divide the power with 4. Right, we will divide the power with 4. 43 by 4. What is the remainder we will get here? 3. Similarly, 44 by 4. What is the remainder we will get here? 0. When remainder is 3, we will take the third power. That is 3 power 3, which is 7. That is satisfied. When remainder is 0, what we will take, ma? When remainder is 0, we will take the fourth power. We will take the fourth power. Okay. I have clearly explained about this in my fourth section, number system fourth session. So please go through that. So here, fourth power is what? 1. So 7 and 1 are satisfied. So we will mark 3. In this manner also you can write your answer. Okay. Next one. Find the unit digit of the expression. Right? Something like this was given for us. 78 whole to the power of 5562 56. See here, for 6, whatever may be the unit digit, we know that it is 6 only. For 6, any power of 6, we will get unit digit as 6 only. Now come to 8. What is the power which was given for us here? 5562 by 4. We need to divide it with 4. And we will try to observe the remainder. What is the remainder we will get here, ma? No, even we know, we are not even bothered about the complete number. Last 2 is enough. Okay, last 2 is enough. No need to worry about the 62 by 4. What is the remainder here we will get? Remainder is 2. If you divide the complete number or last 2, both are same. So we will not bother about. Remainder is 2. That means we need to take 8 square. 8 square. 8 square is what? 64. But we want only the unit digit, right? So here what it becomes? 4. Well and good. Next 7 power 1250. Similarly, we will divide it with 4. Why? Because for 7 also we have 4 chances. Don't bother about these 2. We will consider only 50 by 4. What is the remainder we will get here? 2. Remainder here also we will get 2. That means 7 square. 7 square. 7 square is what? Actually 49. What is the unit digit there? 9. So 9. Okay, these are the unit digits. Now multiply them. 4 6 are 24. We will not bother about 2. We will go with 4. 4 9s are 36. We will not bother about 3. We will consider only 6. So our answer becomes what here? 6. So our answer becomes 6 in this case. In this way, we will find the units digit of this expression. Not only this, any expression. Similarly, this one's here. Find the unit digit, something like this. Okay, please be careful, students. Here the symbol is what? Plus. Plus. So please be careful. In the previous example, I have told you that when 5 and any even number is there directly. Why? Because that is multiplication. But see, in this case, this is addition. This is addition. Okay, this is addition. So please be careful, students. There that is multiplication. So directly you can mark your answer as 0. But in this case, this is not multiplication. This is addition. So any power of 5, what is the unit digit? 5 only. Any power of 6, what will be the unit digit? 6 only. Now here this is 3 power 54. For 3, we have 4 chances, right? What we will do? We will divide power with 4. What is the remainder we will get here? Remainder we will get here is 2. That means 3 square is what? 9. 3 square is what? 9. So 9. 5 plus 6, that is 11. We will not consider. Next, 1 plus 9, it is 10. So our answer here is 0. See here, students, this answer is just coincidence. That's it. 5 and 0, there is no link. 5 and actually there is link, but here it is addition. Pure coincidence, ma. Don't mark it directly 0 whenever you see 5. Please be careful. What is the mathematical symbol they given for you? If it is multiplication, you can directly mark 0. But if it is addition or some other thing, please be careful. In this case, this is purely a coincidence. but this may not happen in each and every case. Okay, right. We will move to our next problem. The last digit of the number obtained by multiplying will be. We need to find the units digit. This is a simple and general question. Go ahead with the units digit. 1 2s are 2. 2 3s are 6. Next 6 4s are 24. We will not bother about this one. Next 4 5s are 20. Or else directly also you can say your answer as 0. Why? Because 5 with any even number, obviously what we will get? 0. 0. Okay, if you see, students, this question is splitted in two parts. That's the reason I was not able to identify it. But even though no problem, 5 with any even number, we know that 0. So from here onwards, you multiply with any number. What is the unit digit we will get here? 0 only. So directly we can mark our answer as 0. We can mark our answer as 0 in this case. Right? Clear? Now, these are some examples from the units digit and remainder theorem, students. So please be careful with this remainder theorem. Try to write the difference between numerator and always try to write the difference between numerator and denominator as 1. And if you get a negative remainder also, please be careful and try to observe it and please convert it into a positive one. Okay. These are the things which I want to discuss under this. Okay. One more example. See here. The difference between the two 3-digit numbers xyz and zyx will be equal to. See here, as I have already told you, how you will write a three-digit number, how you will express xyz, how you will express xyz, 100 into x plus 10 into y plus 1 into z. Similarly, zyx, how you will express it, 100 into z plus 10 into y plus 1 into x. And what we are doing? Difference. We are finding the difference between these two things. See here, 100x minus x, what it becomes? 99x. 10y, these two will get cancelled. Now, minus 100z plus 1z. What it becomes? Minus 99z. Minus 99z. If you take common, what it becomes? 99 times of x minus z. 99 times of x minus z. Okay. So what will be our answer? 99 into difference between x and z. 99 into difference between x and z. Difference between x and z. So please be careful, students. You can expect these type of questions. At least one question from this area. As we have already discussed, this type of questions. How to express the 3-digit number or something like this. Please be careful. They may ask us a question from this area. Okay. Right. Now we will move to our next concept. As I already told you, what is that? Number of zeros. Number of zeros concept. Okay. We are discussing number of zeros concept here. We will discuss the number of zeros concept here. See here, what is number of zeros? What they will do is usually they will give us a product or anything, mostly the product only or factorials. And they will ask us to find the number of zeros. For example, something like this. Okay. 42 into 30 into 45 into to 48, something like this they will give us. Okay. And they will ask us the number of zeros. For example, this sum, I don't know what is the exact value of this, but for example, the output is something like this, 2 4 5 0 0 3 0 0. The number of zeros means what we need to do is we need to count the zeros which are present at the last. So the number of zeros in this answer are only 2. Okay, the number of zeros in this answer are only 2, not 4. We will not consider the zeros which were present at the middle of the answer. We will consider only the zeros which are present at the end. Zeros which are present at the end. Okay, zeros which are present at the end. So here our answer becomes 2. See, this is just an example, not the answer of this one. So, okay, now we will consider only the zeros here. We will consider only the zeros which are present at the last or at the end of the given product. End of the given product. End of the given product. Okay, well and good. Now, tell me, by multiplying which even numbers, which two numbers, usually, general, small digits, we will get the 0. By multiplying which two numbers or two digits, whatever it may be. See here, when you multiply 2 with 5, what is the output? 0. When you multiply 4 with 5, what is the output? 0. Unit digit. I'm telling the 0 at the last. 6 into 5, 30. Similarly, 8 into 5, 40. So, when you multiply 5 with any even number, what we will get is, we will get a 0. We will get a 0 at the last. When we multiply 5 with any even number, we will get a 0 at the end. We will get a 0 at the end. Clear, right? You multiply 5 with any even number. That means, see here, in a product, if you are able to find, see here, even number means, even number consists definitely 2, right? 2 into 2. This is 2 into 3. What it is? 2 into 4. Or else 2 into 2 into 2. That means a pair of 2 and 5, a pair of 2 and 5 will give us a 0. Will give us a 0 at end. 0 at end. Okay. So, what will be our goal in this type of questions is very simple. A pair of 2 and 5 will give us a 0. A pair of 2 and 5 will give us a 0 at the end. 0, 1, 0. Okay. We need to find how many pairs of 2 and 5 will be there in the given question. So, if you are able to find how many pairs of 0, 2 and 5 in the given question, then easily we can tell our number of zeros at the end of the product. For example, what is the question which we have given? 42 into 30 into 45 into 48. This is the question, right? So we will try to split this 42 into 2s and 5s for time being. So if I do prime factorization, what I can write is 42. How I can write this 42? 2 into 3 into 7. 2 3s are 6, 6 7s are 42. Similarly, what I can write? 32 into 3 into 5. 2 into 3 into 5. I am doing prime factorization. Okay. I will tell you prime factorization later on. There will be one small concept there. Next, for 45, what I can write? 3 into 3 into 5. That means I am splitting in this manner. See here, students. Don't be get confused. 2 is 21. Okay, right? So 3 7s. 2 3 7. Similarly, 30 also. Okay, 2 15s. 3 5s. So 2 into 3 into 5. In this manner, I am splitting this one, but directly. So 48, what I can do? 2 into 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 3, 48. 16 into 3, 48. So in this manner. So finally, what I can write the output? 2 power 1, 2, 3, 4, 5, 6. 2 power 6 into 3 power 1, 2, 3, 4, 5 into 5 power 1, 2 into 7 power 1. 7 power 1. So what we need to do is, we need to denote the given expression in the power slash something like this. Now tell me, how many pairs of 2 and 5 are possible for us here, ma? How many pairs of 2 and 5 are possible for us here? Here 2, how many 2s are there for us? 6. How many 5s are there for us? 2. How many 5s are there for us? Only 2. Only 2. By using these 6 2s and 2 5s, 6 2s and 2 5s, how many pairs of 2 and 5s we can make? We can make 2 pairs. Only 2 pairs. So the number of zeros here are 2 zeros at the end. 2 zeros at the end. 2 zeros at the end. So the number of zeros in this product are how many? 2 zeros. In this product are how many? Is 2 zeros. See here, students, if the question is a general question, something like this, what we will do is, we will split the question in this manner. Okay, whatever I will solve one more example for your better understanding. 24 into 25 into 26 into 20, something like this. There is one example in this manner. First of all, as I have told you, split them. 2 into 2 into 2 into 3. 2 2s are 4, 4 2s are 8, 8 3s are 24. Next 25, how I can split? 5 into 5. Next 26, how I can split? 2 into 13. Next 20, how I can split? 2 into 2 into 5. 2 into 2 into 5. Now, how I can express this one? 2 to the power of 1, 2, 3, 4, 5, 6 into 3 to the power of 1 into 5 to the power of 1, 2, 3 into 13 to the power of 1. I can express this given question in this manner. And as I have already told you, we will bother only about 2 power and 5 power. So what with 6 twos and 3 fives, how many pairs of 2 and 5 we can make here? 3. So the number of zeros in this case are 3. The number of zeros in this case are 3 zeros. We will get 3 zeros at the end of the product. 3 zeros at the end of the product. Okay. In this manner, we will solve it. But what happens is, usually they may ask a question in this manner or not. We cannot say. But what they are doing is, they are asking the question in factorials. They are asking the question in factorials. Factorials. Okay. See here, students. Find the number of zeros. Find the number of zeros for 50 factorial. They are asking 50 factorial. Usually, what is meant by 50 factorial, ma? What is the meaning of 50 factorial? 1 into 2 into 3 into 4 into 5 into 6 into 7 into and so on up to 50. We need to multiply the numbers up to 50. If you see in this manner, students, please see here, while observing the factorials, what will be our major target in this case? What will be our, we need to find the power of 2 and powers of 5. Okay, we will not bother about the remaining things. We will concentrate only on the 2's powers and 3's powers. 2's powers and 3's powers. Okay. So for this reason, see, when you observe here, 2 will be many in number, right? Almost a minimum of 1 2 in every even number. 1 2 in every even number. It can be more than 2 or 1 also. Why? Because see, 4, if you see, take 4, you can write it as 2 into 2. If it is 6, you can write it as 2 into 3. If it is 8, what you can write? 2 into 2 into 2. That means 2's will be many in number. 2's will be many in number. So the minority, the minimum number means what we will have? Only the powers of 5. So obviously the power of 5 will be less than the power of 2. Why? Because this is factorial case. In the case of factorial, students, anyway 2's will be many in number. So we will not bother about 2's. Our concentration will be only on 5's. Okay. How many 5's are possible for us? Now tell me what are the possible chances for 5's in this case, ma? Actually at 5. Okay, I am checking only the possibility of 5's. At 10, at 15, am I correct or not? At 20, at 25, nothing but the multiples of 5. Okay, at 30, at 35, okay, at 40, at 45 and 50. This is the area where I will get 5, 5, 5, 5, 5, 5. Okay, 5, 5. See here. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So will 10 be our answer in this case? No, no, not 10. Why? Because see, when you see 25, ma, actually what we can write it as 5 into 5. 5 into 5. There are 2 5's. When it comes to 50, how we can write 5 into 5 into 2. 5 into 5 into 2. So there are 2 5's in this case and 2 5's in this case. So total 10. 10 plus 2, that is equal to 12. 10 plus 2, that is equal to 12. Okay, this factorial is very small. So I have written them and I have counted them. Well and good. Well and good. Happy. But if the question is something like this, 250 factorial. Not 250. For time being, I will take only 120. Later on, I will tell you. 120 factorial is there. 120 factorial is there. Then how I need to solve? Can I write all the numbers from 5 to 120 and do it? No, no. So to avoid this problem, what we need to do is, we need to divide the given number with powers of 5. With the powers of 5 and add their quotients. Add their quotients. That means 120 by 5 power 1. 120 by 5 power 1 plus 120 by 5 square plus 120 by 5 cube. Why I am going with the powers of 5 means, see here, 5, 25. 25 in 25 we will have 2. 5 cube means what? 125. In this we will have 3 in this manner. So in this manner we will do it and we will add the quotients. Okay, add the quotients ma. Add the quotients. 120 by 5. 120 by 5. What is the quotient we will get here? 120 by 5. 24. 24. Okay, similarly 125, 120 by 5 square means what actually it is? 25. 25. 25. Quotient becomes what here? 4. Once again I am saying these 24, 4 are quotients. 120 by 125. 120 by 125. What is the quotient we will get here? 0. Why? Because 120, 125. 0, 0. Right? Why? Because that value is smaller than this value. Remainder will be 120, but the quotient will be what? 0. From here onwards, take whatever the power of 5, the quotient will become 0, right? So the number of zeros in this case will be how many? 28 in number. 28 in number. 28 in number. So please observe here. Now we will solve the same question. This one with this logic. What I need to do? 50 by 5 plus 50 by 5 square. That is nothing but 25 plus 50 by 5 cube, which is equal to 125, and so on and so on. 5 ones, 5 tens. This is quotient. Once again I am saying 25 ones, 25 twos. Next 125. What is the quotient we will get here? 0. So 10 plus 2. What it is? 12. 12. In this manner, we will find the number of zeros in the case of factorials. Factorials. Now we will solve some examples so that you will have more clarity. Okay, let me take another example. 240 factorials. See, actually, a pair of 2 and 5 will give us 1 0. A pair of 2 and 5 will give us 1 0. But in these factorial cases, we will have many number of 2's. So we are not bothering about 2's. We will concentrate only on 5's. So how we will find the number of 5's means divide the given number with 5 powers. 240 by 5 square. Similarly, 240 by 5 cube. Okay, 240 by 5 to the power of 4 and so on. And observe the quotients. Observe the quotients and add them. And add them. Okay, for this reason, what happens to this? Oh, actually, I am expanding it for better understanding. And so on. 5 ones, 5 48. Similarly, 25 9 times 225. 225. This is quotient. 9 is quotient. Actually, 240 is not exactly divisible by 25. We will not bother about it, but we will get a quotient of 9. Quotient 9. So please be careful with this one. Similarly, 125 quotient we will get 1. Okay, here anyway the quotient becomes what? 0. From here onwards, all the numbers will become 0. Why? Because numerator is smaller than denominator. Numerator is smaller than denominator. So what happens to this now? 48 plus 9 plus 1 plus 0 plus 0, 0, 0. Anyway, all these are zeros only. We will not bother about them. Okay, 9 plus 1 is 10. 10 plus 48 is 58. So the number of zeros in this case is 58 zeros. 58 zeros. See students, this 48, 9, 1, all these are quotients. Actually 240, once again I am repeating, 240 is not exactly divisible by 25, but 9 is the quotient which we will get in this case. Okay, in this manner we will find the number of zeros. Number of zeros means nothing. Your target should be only one thing. You need to find the pairs of 2 and 5. 2 and 5. If the case is regarding factorials, no need to worry about 2's also. Why? Because anyway, we will have many number of 2's. We will concentrate only on 5's. We will concentrate only on 5's and we will calculate the number of 5's. and according to that, we will write our final answer. Okay. Now see this question. No? How many zeros are there at the end of the following product? 1, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Please be careful, students. All these are what? Multiples of 5, but not the factorial. These are all what? Multiples of 5. In this case, there is a chance of 2 in. Okay, now anyway, as I already told you, we will what we will do is we will try to express the given term in terms of 2s and 5s, right? Do the same thing here. Okay, 1 anyway, it is 1. I will write the question first. And one suggestion for you people, please don't count with the help of fingers or something like this. Anyway, we have enough time. We will have enough time to solve the problem. So please put your pen on the paper and then only count them so that you will get the correct answer. Otherwise, you may go wrong. You will get a wrong answer. So 5, it becomes what? 5 into 1. 10, 5 into 2. 15, 5 into 3. 20, 5 into 2 into 2. 25, 5 into 5. 30, 5 into 2 into 3. 35, 5 into 7. 40, 5 into 2 into 2 into 2. Okay, 45, 5 into 3 into 3. 50, 5 into 5 into 2. 55, 5 into 11. 60, 5 into 3 into 2 into 2. Okay, I will write here clearly. 5 into 3 into 2 into 2. Okay, now please observe this question. There is no rule that in each and every case, always, what we can say, 5s will be minimum. There will be some cases where we may also have 2 in a minority. For example, see here, check how many 5s are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 5s are there. 5 power 14. When it comes to 2s, please count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10. Don't think that always the power of 5 will be in minimum. In some cases, like this, sometimes the power of 2 can also be in minimum. So please be careful. Here 14 5s are there, 10 2s are there. 14 5s are there and 10 2s are there. So tell me how many pairs of 5 and 2 are possible? 10 pairs. If 10 pairs of 5 and 2 are possible, the number of zeros will be what? 10. The number of zeros will be what? 10. So only in the case of factorials, we will neglect the power of 2, but not in the remaining cases. Please keep this thing in your mind. Only in the cases of factorials, we will neglect 2s. But in the remaining cases, definitely we will find the 2s and 5s. Okay, so our answer here will become what? This one. Okay. So our answer here is this one. In this manner, we will find the number of zeros. Number of zeros. Okay. So students, please practice and the questions from these concepts which we have discussed till now. Till now, we have finished 5 classes under this number system. Okay. Still, there are a few more things which we need to discuss under this number system, and then only we will move to the next concept. Okay. Please keep this thing in your mind and watch all the videos one after other. Then only you will have an idea that how we are solving the problems and how these things are interlinked. Okay. Otherwise, next what we will do is we will solve the questions which are interlinked between the numbers and permutations and combinations. Okay. There are some questions which are interlinked between these two areas. Okay. We will solve the questions based on this area in our next session. Right? If you have any suggestions or any doubts, whatever it may be, please express your thoughts in the comment section. Okay, so that we will try to improve ourselves. Thank you very much. We will see in our next session.